Hello guys, welcome to yet another video. So in this video I will be guiding you on how you can be able to clean the data using Python. We'll be using a module known as Pandas to be specific. We'll also be using data from Kaggle. It is a Titanic dataset. You can go ahead and download it. I'll put a link down below. We'll also be using Jupyter Notebook for the entire video. Before proceed, it is crucial to understand that there are certain standards that are supposed to guide you when you're cleaning your data. Some of these standards include checking for completeness, consistency, there's a few others. I had to mention it for the absolute beginners if at all you don't have any knowledge about that. So maybe you can go ahead and check that out. Let us now begin. We'll begin by first importing pandas. So pandas is used for data manipulation. Let us go ahead and run that. The next step is that we are going to specify our file path where the Titanic dataset is located. So we have a variable there known as file path. Then we are going to copy our file path. Once you've specified your file path, let us go ahead and tell Pandas to read our CSV file and load it in a data-like structure. So don't forget to run it first. How do we do that? We are going to create a variable known as Titanic data. Now the question is, why did we specified our file path, then we want Pandas to read our file? It's because we want it to display how our file looks like, because we cannot proceed on cleaning the data if at all we do not understand how the data looks like. So we need to understand how the data looks like before we proceed now on cleaning the data. Let us go ahead and run that. Now this is how our data looks like. So from what you can see from our index, the rows start from 0 to 890. So we have 891 rows, and we also have 12 columns. So it is crucial you get to understand what each column stands for, or what each column represents. Here's our first column on passenger ID. Then you have for those who survived, and they are represented by either 0 or 1. 0 for those ones who did not survive, and 1 for those ones who survived. Then you have the passenger class, which is either first class, second, or the third class. Then you have a column for name, where we have the second name and the first name. So here we can go ahead and split it so that you have the first name on one column and the second on another column. Then you have the gender here, which could either be a male or a female. Then we have age here. And also, as you can see, we have rows that do not have numbers. So those are some of the things that we are going to work on when you're cleaning the data. Then you have SIB for sibling and SP for spouse. So we are saying the number of siblings or spouse that were aboard, parents and children. So the number of parents or children that were aboard. We also have the ticket number, which is not standard, as you can see. We'll also work on that. We also have the fare, which is a float, as you can see. It is a number, but a float. We also have cabin here. We also have rows that do not have numbers. We also have embarked. These are ports where the passengers embarked. So you have an S, a C, and a Q. So that is how our data looks like. Now, supposing we had more than 12 columns, let's say, for example, maybe 20 columns. Maybe if the data was huge and you wanted to know the structure of the data, so this is what you'll do. So we'll have it as, so this will give you the information about the structure of your data. Just in summary, just run that. So if you run it, you can see the columns that you have, and you have 12 columns in total based on the index. Then you can see null counts. So as you can see, for example, for the passenger ID, the rows that have values, all the rows have values, because we said you have 891 entries, as well for the survived, and also the data type, as you can see. So you also have a summary of the data types, the floats, how many are they? Object here is a string, so yeah. So in summary, that is how you can check for the structure of the data. We said for the name, we want to split. We have the last name and the first name. So we want to split such that you have two columns. You have a column for the first name and a column for the last name. Okay, let us go ahead and do that. We want to split the name column into first and last name. So in order for us to do that, we'll have it as Titanic data. So we want to have a last name and a first name in the Titanic data. So we're going to take our name column. And what we're going to do is that we will split it into now our last and our first name. So we are splitting our name into the first and the last name. Why last and the first name? Because we have our last name, then our first. If it were first, then last, then it would have been first, then last in that order. Then you have our Titanic data. We are taking, in the Titanic data, we are taking the name column, then we are splitting it. Wherever there is a comma, that is where the split is going to happen. Why expand true? The expand true makes sure that the split parts go into separate columns instead of staying into a single column, because we expect the last name to be on a different column and the first name to be on a different column. Yeah. So we can go ahead and run that. So once that is done, what you want to do is that in the first name, let us go ahead and remove any spaces. Now the split ensures that any spaces from the first name are removed. Maybe we can go ahead and run. Let's see. Now this is how our data looks like now. As you can see, now we have 14 columns. We still have the name column. So what we are gonna do now is to drop this first name column. Let's go ahead and drop it. We are dropping the name column from the Titanic data. We are dropping the column name. Now, is the in trace is equal to true necessary? Yes. This ensures that the change is made directly to the original data. So let us go ahead and run that to see. Now, in order to see if there are any changes, let us go ahead and have our Titanic data. Now, as you can see, now we have 13 columns. Yeah, we have 13 columns, and previously we had the name column. Now we've dropped it, there's no name column. Now let us go ahead and arrange our columns. The last name and the first name are at the end of the columns. Maybe we'd want them to be after the passenger ID. So let us go ahead and move them between the passenger ID and the survived. So we are rearranging the first name and the second name column. So it is the Titanic data. We'll use insert. Let us go back. So as far as the columns are concerned, passenger ID here is index 0. We'd want the first name to be index, then 1. Yeah. Then the last name will be index 2. So we'll have it as insert. Then we want the first name to be index 1. Then first name. But you cannot have first name as index 1 if you haven't removed the first name from where it is. So what we do, we'll use the pop function. Let's go back. The insert is used to add columns to a specific location. Like I explained, passenger ID is index 0. Survived is 1. So we want the first name to be here at index 1. So you'll come and specify you want your first name to be index 1. Then you cannot be able to move it without popping this first name. Popping as in what? So pop removes the first name. What it's gonna do is that it will remove this first name, but not deleting it. It will just remove it until you need it. It just removes the column, keeps the date of the first name column, but does not delete the first name column, the date of the first name column. Yeah. Then let us go ahead and do the same for the second name. So I'll just go ahead and copy that, then change whatever that is necessary. So we want the second name to be in index 2. Then you have it as we have it as the last name, Titanic data, again the last name. So let us go ahead and run that to see. Now, as you can see, just like we wanted it to be, we have the passenger ID as 0 index, if that makes sense. Then you have the first name now as the first index. You see the way the rows are numbering? That is the same way the columns would number if at all we were to have something like a list. Handle that. So the next step, let us go ahead and check if we have any duplicates. So we're checking for duplicates. If we have them, we remove them. So let us go ahead and check for duplicates. Our column in focus is the passenger ID. We want to know if there were any duplicates in the passenger ID. If we have a passenger whose record was taken twice or even more, so that we remove that. So we'll create a variable known as duplicates. Like we said, we are checking it in a subset known as passenger ID. Let's go ahead and view our data, see. So based on our results, we do not have any duplicates. Now let us go back and view our data. In our first name column, you can see that you have a combination of the honorifics and the first name. We want to do a separation where the honorifics will be on a different column and the first name on a different column as well. So let us go ahead and do that. So what you're going to do first is that we are going to extract the list of honorifics that are available in the first name column. So we want the list, we want to know how many honorifics are there so that we can go ahead now and do the extraction. Now we want to do an extraction of the list of all the honorifics in the first name column. So we want to know how many honorifics are there so that you are able to now extract the honorifics from the first name column and have it in a different column, and eventually remove the honorifics from the first name column. So let us go ahead and create a variable. We'll name it honorifics. So you have to understand that we are trying to look for the honorifics in the first name column. That is why we have it as the first name there. Then we want to go ahead and do the extraction now. We want the list of all the honorifics. So what this does is that the line looks through the first name column and tries to find the honorifics like the Mr. or the Miss. So if you don't understand, an honorific is a title used before someone's name, such as, like I said, the Mr., then the Miss, and what have you. So what this line does is that it looks through the first name or the Titanic data frame for that matter, and tries to find honorifics like the Mr., Miss, and what have you. So for those who are new, honorifics is a title used before someone's name, like we say the Mr., Miss, and what have you. Yeah, this one is a way to search through the text of a word that matches a specific pattern. So we have this pattern, we've specified our pattern here. So you're saying you are going to search for our honorifics from the start of a word, then looks for any word, we have the W plus there, that ends with a period we've specified there, like the Mr. starting from this word. Then we're searching through the word and we make sure that it ends with a full stop or a period. The expand folds here is very necessary because we want to ensure that we get a single column, not multiple columns as the result. We need it as a single column. Now that being said, now in our next step we want to go ahead and remove any missing or empty values from the honorifics column. So let us go ahead and do that. We will create a variable known as honorifics list and drop those values that are missing or empty. Let us include a comment there. Now what we've done is that we've gone ahead and dropped the missing values. Then we want to keep the unique ones, so we have it as. So let us improve on that, and so like we said, the unique gets a list of all the unique honorifics found, meaning they're not duplicates. This will give us something like a Mr., then a Miss, a Doctor, etc. So let us go ahead and view our list. Now that you have a list of all the honorifics, you can now go ahead and create a new column, name it honorifics, then go ahead and do the extraction, where we will now store all the honorifics on that column. So we are having the honorifics column in the Titanic data frame. Then we'll be doing the extraction now from the first name column. Now let us go ahead and do the extraction now. Like I said, we are creating the honorifics column in the Titanic data frame, and we are doing the extraction in the first name column. Then this joins all the items in the honorifics list with the OR operator. This is an OR operator in our regular expression. So we'll go ahead and close the parentheses for the regular expression group. Then the positive signs here combines this pattern into one group for the strings extraction method. I already explained why you're using the expand is equals to false. So let us go ahead and run that first we see. So it seems that's okay. The code is okay. Maybe we'd want to see how our data looks like. So let's go ahead and do that. Sorry, there's an error there. Titanic. That's okay. So this is how our data looks like. As you can see, we now have a column for the honorifics, and our first name still has the honorifics. So what you're going to do in the next step is that we are going to remove now the honorifics in the first name column. So in our data frame, Titanic data, we are handling the first name column. That's where you're going to remove the honorifics. We're using this method, the replace method, because we want to remove all the honorifics. So let's just go ahead and do that. Our regular expression is equal to true here because it tells Pandas to treat the pattern honorific list as a regular pattern. So this looks for any honorifics in the first name column and replaces them with a space. It's going to replace them with this space over here that is specified. For example, we have Mr. Patrick here, then we'll just have it as Patrick. Why the regular expression is equal to true, it tells Pandas to treat the pattern, the honorific list, as a regular expression. So once that is done, let us go ahead now and remove any stray periods. By stray periods, I mean, for example, if we have this as Mr. Patrick, we have the Mr. and the period there in the honorifics column. Then on the first name column, we'll have something like a period, then Patrick. Let us go ahead and remove it. So we are saying we are replacing any period or full stop with a space, a blank space. Then again, we want to remove any spaces in the front of the name or at the back of the name, any leading or trailing spaces in that name. So let us go ahead and do that. So this in summary ensures that you have a clean name. So once that is done, let us go ahead and run it. We see it seems you have an error. Let me fix it real quick. And that's okay. We have the first name, the honorifics list. Yeah, maybe you'd want to move the honorific list to be after the passenger ID. Already explained that previously. I'll just go ahead and copy it. Then change whatever is necessary to have these as honorifics. What index do you want it to be? Have index 0, the passenger ID, then we want it to be in index 1. So let us go ahead and change that. Let's see. They have the honorifics as the second column. That's okay. Now let us go back to our data structure. We see, like we said previously, for the age, the cabin, and the impact, we have missing values. So for the age, you have 177 missing values. Then for the cabin, we have 687 missing values. Then for the impact, we have only 2 missing values. So let us go ahead and handle these missing values based on this context. So for the age, what I'm going to do is that let us go ahead and replace the values with a mean or a median age. Then for the cabin, because you have so many missing values, you can go ahead and drop the column, or you can go ahead and replace the missing values with unknown. So that's what you're gonna do. Then as far as impact is concerned, you have only 2 missing values, so we'll just go ahead and replace the missing values with the most frequent values. So in the age column, I will be replacing it with the median. Now, why the median? Because it has 177 missing values. So instead of dropping those rows, and I feel like the median will be most preferable because it is less affected by the extreme values, that is the outliers, compared to the mean. So let us go ahead and do the replacement using the median. So here I do the replacement on the age column. This section here means we are selecting the age column in our data frame. So we are using the NA here because it replaces the missing values in the column with a specified value, and in this case we are replacing it with a median. So what this does is that it calculates the median of the age column, which is used now to fill the missing values. So let us go ahead and run that to see if there is any error. Yeah, there's an error. We go ahead and fix that real quick. So that's okay. Let us go ahead and now handle the cabin column. So for the cabin column, what we're going to do is that we are going to replace the missing values with the unknown, the term unknown. So let us go ahead and select our cabin column. This is the same thing. We are handling the cabin column. We want to replace the cabin column with the unknown for all the missing values. So let us go ahead and run that to see. So that's okay. Let's go ahead and do now the impacts. And in this case, the most frequent value is the mode. So let us go ahead and do that. So the same thing applies here. We are handling the embark column in our data frame. So we want to do a replacement for the missing values, and we are replacing it with the mode. Now the question is, why do we have this 0 here? It's because it retrieves the first value if there are multiple modes. So if we have multiple modes, what's gonna do is that it will give us the first value. Yeah, so let us go ahead and run that to see if we have any errors. So that's okay. We can view our data. This is now how our data looks like, as you can see in the cabin. So in order for us to view this in a simpler way, we can just go ahead and view our data structure. Now, like I said, it is easier to view it this way. As you can see, there are no missing values, so that it has been sorted out, so that is done. Now let us go back and just view our data from here. Now, as far as the ticket is concerned, we have irregular formatting. Some ticket numbers are inconsistent in format. So for example, you have regular formatting. Some ticket numbers are inconsistent in format. For example, you might see a ticket number, we have A/5, then a number, then you have a stone, /02, then you have a period there, then a number. So the formatting here is inconsistent. So if we were to do a predictive model, like let's say we wanted to predict the survival, the ticket number might not be useful. Let us go ahead and drop the ticket number. and you're saying you're dropping the tickets column. Then you're saying the axis is equals to 1. So axis is equals to 1 because this is how we specify that we are dropping a column. If at all we were dropping a row, then it would have been axis is equals to 0. So let us go ahead and run that. We see there's an error, sorry. Let's run it again. Now we've come to the end of our data cleaning process. As far as the fare is concerned, maybe you can go ahead and have it as 2 decimal places. Go ahead and try that yourself, you see. I'll go ahead and show you how you can be able now to save your data. So you have it as Titanic data. So I've just copied my file path where I'd want my Titanic data to be saved, and I've named it Titanic cleaned. Let us go ahead and run that, we see. Now my Titanic cleaned data is saved under downloads, so you can go ahead and specify your path. If you found this video informative, can you do give it a thumbs up? Don't forget to subscribe. Do get me to 500 subscribers. I'll see you guys in the next video.